As Hayes 2010 suggested, cross-curricular teaching and learning has strong links with a constructivist view of learning, as children work collaboratively and learn from their own direct experiences. Within primary education, the focus of a cross-curricular approach has shifted, moving to and from the forefront of teaching methods. Haddow, 1931, and Plowden, 1967, suggested that learning, especially the primary curriculum, should focus on activities and experiences as opposed to acquiring knowledge and storing facts. However, these recommendations were not supported by the national curriculum, which subdivided primary learning into 10 distinct subjects. This meant cross-curricular teaching all but disappeared between 1997 and 2003. Not everyone is an advocate of a cross-curricular approach. Cerniak, 2007, Parkinson, 2010, and Barnes, 2011, concluded that by using this approach, the individual subjects lose their identity and boundaries become blurred. Alexander, Rose, and Woodhead, 1995, criticised poorly planned thematic or topic work within primary teaching, noting it resulted in superficial learning. This is where the pupils retain the surface information, but do not understand the deeper meaning and are, therefore, unable to apply it in all different contexts. However, this report failed to mention that a high standard of topic work was produced from well-planned lessons and teaching. As mentioned by Ofsted 2008 and Jarvis 2009, studies have demonstrated that by using the 1999 national curriculum and the laid-out programmes of study to organise and structure planning of cross-curricular work is an effective approach to ensure an appropriate balance. Williams 2008 is an advocate for both cross-curricular teaching and learning, stating that it encourages children's involvement, which has a direct impact on their motivation and their learning. If a child is immersed in a task, they do not feel like they are being taught, but are learning through experiences and applying this themselves. It also allows for a wider breadth of study, so encompasses more children. For example, it may be the science that holds the child's interest, whereas for others it may be the maths. Either way, the child is enjoying learning and applying new skills, which, as Piaget 1973 said, at the heart of every process is discovery, and understanding is built step by step through learners' active involvement. It is important for children to have complete understanding, as this allows them to apply the knowledge and makes it relevant. As Bruner 1966 concurred, to instruct someone is not a matter of getting him to commit results to mind, rather it is to teach him to participate in the process that makes possible the establishment of knowledge. Within the 1999 curriculum, each individual requirement stated what other subject this knowledge was building on, and not by suggesting any cross-curricular themes, methods or approaches. However, in the new curriculum, 2013, subject links are suggested in the section header, along with details of how these skills should be applied in other areas. This is also apparent in other curricula from other countries, such as the Curriculum for Excellence in Scotland, Northern Ireland and New Zealand. These make the links between subjects, which helps to support and enable full understanding and applicability. This has led to there being many different approaches to cross-curricular teaching, such as a thematic, traditional and interdisciplinary approach. As this assignment is primarily concerned with how other subjects can support a child's learning in science, the interdisciplinary approach will be the main focus. This approach is used as the knowledge and understanding learned in one subject complements or supports a particular science topic, or because they share certain skills. Interdisciplinary teaching is often seen as a way to address some of the recurring problems in education, such as fragmentation and isolated skill instruction. It is also seen as a way to support goals such as transferring of learning, teaching students to think and reason, and providing a curriculum more relevant to students, thus supporting and expanding a child's knowledge and understanding. According to Appleby, Langer and Mullis, 1989, the knowledge children are learning within the core subjects is not being applied effectively in other areas, such as thinking and reasoning. Collins, Brown and Newman, also 1989, stated that the interdisciplinary cross-curricular approach provided the means for students to use their knowledge from one context and apply it in other situations, both in a school environment and outside. As Barnes 2011 states, effective and lasting learning in one subject is often provoked by calling upon another. So, for example, the use of ICT in maths and science. As the National Curriculum 2013 states, computing has deep links with mathematics, science and design technology and provides insights into both natural and artificial systems. ICT, or Information and Communication Technology, not only helps reinforce the concepts taught in both maths and science, it allows the children to apply this knowledge in varying ways. For example, creating a table to collect data, analysing the information and creating graphs to display the results. The following are teachers' and pupils' feedback regarding a newly implemented ICT-based maths focus.
What's really interesting about the way the pupils are working here is that they're actually given the opportunity to create something, and in doing so they're really testing their ideas out and using the software to help them to see what's going on. So they'll be learning about what will be good numbers to choose in order to get a shape which has got an order of rotational symmetry that makes sense to them. I've seen this type of activity used with pupils from year 4 to year 9, and in every case there's been significant learning taking place as a direct result of the pupils watching the different graphs appear on the screen and really correcting and using that ICT, the feedback that they're getting from that, to be able to correct and modify what they're doing.
Everybody does that!
And really challenging the concepts that they've got about distance.
It's quite easy to use, and the children can find out how to use it quite easily themselves. So from my point of view, it's revising my questioning techniques so that I can actually sort of get the misconceptions out of them, and hopefully it just breed their interest in actually in the whole maths concepts.
They're not sitting waiting while you're writing. They're with it all the time, and the lesson you should get much more covered, and hopefully they would learn a lot more.
When I brought them into the computer suite last week and then practiced on the whiteboard, the things that they were remembering I was absolutely amazed about, and if I'd done that in the classroom I don't think they would have.
It's just more about exploring, I think, whereas normally we just taught the facts, I think. So, yeah, it's more about investigating.
Yeah, I feel it's much more relaxed because Miss Guy's just letting us investigate on our own. She's not like lecturing us about it or anything, so I think it's better.
It's slightly different because normally we work out of exercise books.
And we've had to work really hard on that because what they don't know is a skill. They know the knowledge. And the very confident teachers, once we give them the skills, they are delivering wonderful lessons.
As the National Curriculum 2013 explains, pupils should learn to use a variety of approaches to answer relevant scientific questions. Some of the types of scientific inquiry include maths-based investigations, such as pattern seeking, observing over time, and comparative tests. It also states that pupils should seek answers to questions through collecting, analysing, and presenting data, so by using their maths skills and knowledge. There are many different ways of implementing these maths skills to help keep children focused and actively learning. Using different ICT is a good way of doing this. As Ransom 1999 explains, ICT can also enhance opportunities for differentiation and allows pupils to work at their own pace independently. Not all technology needs to be used in the same way, or different groups of pupils can have different tasks to do. These may be based upon their ability level or mixed to allow for support from their peers and growth in their knowledge and skills. If using ICT individually, pupils can work at their own pace and may not feel as pressured to be correct, as it can allow for trial and error. All of this supports and enhances the child's self-esteem and confidence. This in turn means the child is enjoying the experience and the task as they feel empowered, and not only are they gaining knowledge, but they will also be able to apply these skills in different situations and contexts. This is further corroborated by Hayes 2010, who stated that well-planned cross-curricular work helps children make sense of their learning because knowledge and skills learned in one subject are used to reinforce and support learning in other subjects. As one of the subjects is acting as a tool, this is referring to the interdisciplinary approach. Interdisciplinary teaching allows teachers and learners to make connections across learning through exploring clear and relevant links across the curriculum. For example, if learning probability in maths, this could coincide with science work on DNA and genetics. This would support the pupils to better understand both probability as a mathematical concept and its application to genetics. Interdisciplinary teaching supports the use and application of what has been taught and learnt in new and different ways. It provides opportunities for deepening learning, for example through answering big questions, exploring an issue, solving problems, or completing a final project. Following an in-school case study, Romsey 1999 ascertained several distinct advantages to a cross-curricular programme, including that the student became more interested in actually learning maths and science. Another discovery, according to the Japanese teacher Saiki 1998, using a cross-curricular integrated learning approach helped the students realise and cultivate a zest for living by discovering and solving problems by themselves. They also found that pupils were able to manipulate the details and pose their own problems, thus using the skills, tools and knowledge they had retained to answer and explain the solution. So using this cross-curricular approach is empowering the child and providing them with the skills and tools to apply this knowledge. It is not limited to just applying them between maths and science, but in everyday situations and experiences, whether these are within a learning environment or not. Having reinforced maths teaching within different subject areas and enabling various skills to be used and manipulated in different ways enables a student to fully understand and implement the knowledge. So not only are good numeracy skills important for learning across all curricular areas within a learning environment, but they are also essential for life after school. Although there are those who do not advocate the cross-curricular approach, such as Mugis and Reynolds, Jarvis and Laurie, the evidence does appear to be more favourable towards using a cross-curricular approach and the benefits of this. Using an interdisciplinary approach enables the students and their teachers to advance in many areas, such as critical thinking, communication, creativity, pedagogy and essential academia. So it supports and enhances learning and teaching in all areas, including maths and science.